Hi everyone. Thank you for joining me today in this session. I'm just going to apologize up front. We've got some construction going on in the building, so if you hear some loud banging, I apologize. And obviously my partner is working from home, so yeah. I've got everything closed, so we should be good to go. Today I'll be taking you through kind of how we at Absa have gone from our old legacy ways of working and kind of changing that up into how we become very successful at deploying data science products within the organization. And the structure of this talk is going to be along the lines of the past, where we were, the present, where we are now, and the future, how we plan on kind of improving this and iterating upon it moving forward into the future. Firstly, who am I? My name is Daniel Wertheimer, and I'm a data scientist and machine learning engineer at Absa. And yeah, I've been there for about 3 years. A lot of my knowledge about Absa goes back because when I first came into the organization, I really didn't understand how things were working. It was very strange for me. And prior to being at the bank, I was in consulting. So that's me. I guess the next question is where was Absa, right? So when I joined the bank back in 2017, there was a lot of stuff happening at the bank in terms of analytics, right? Absa had been really investing in analytics since about 2015, and there were a lot of products that were being spun up very, very quickly because we had the capability. We were busy building out a really solid infrastructure, and what happened was that we saw this kind of growth over the years, and the number of products really increased exponentially. And I mean, this was great for the organization because we were really showcasing what we were and what we had. However, it got to the stage where at the end of 2017 we had a lot of products, but they were all built on legacy infrastructure, which, as I'm sure you all know, is not really sustainable. And we kind of, well, from a chief technology office, there was a push to then start driving savings and move over onto cheaper platforms, right? And also this exponential growth of analytics projects just wasn't sustainable, right? What happened next was this survival of the fittest, right? It turns out that a lot of the data products that we built weren't sustainable, and there was, along with cutting costs, there was a reduction of costs in business as usual, BAU activity, and as a result, the support for a lot of these data products kind of started decreasing. And at the end of the day, it was what were our strategic goals, which data projects aligned to those, and we're going to stick with those, and the rest we're kind of going to have to slowly kill off or push them back into the business, right? Federate the data science and data product activity and allow them to run with it themselves. So that's what happened. And this is one such of our surviving analytics projects. It's called Pocket Flow, or data products. This is Pocket Flow. It's a really cool dashboard that we provide to our corporate clients that gives them a view of spend and competitive spend and so on. One of the things, I mean, it's incredibly impressive technical work, right? There's few million transactions that move through here a day. You can a few 100 million a year. However, it's really just a dashboard with some fancy analytics. There's actually no data science, or at least there wasn't any data science on the back end of this beforehand. And at the end of the day, when I joined the bank back in 2017, when we went into to engage, so as a central data science team, we went to engage with the business. This is kind of what they expected. They expected dashboards, and we were happy to oblige them with that, because at the end of the day, business wanted data science. Everybody wants data science, but they're not entirely sure what data science is, and they thought it was a dashboard. And we realized very quickly that when you go and you have these engagements and they want a dashboard, and you want to do data science, and you can see that there's value to add within that business from a data science perspective. If you don't oblige them with the dashboard, you're not going to get any further, right? So we ended up creating a lot of dashboards, and it was valuable to them, but it wasn't the type of value that you'd get out of data science. And the question is, like, what is the value of data science? And at the end of the day, it's not the dashboard, because that's what MI and BI is for. They build dashboards. It's the integration on the back end. And at the end of the day, it's something that looks like this, which is just really not sexy, right? It's not sexy data science, but this is where the value lies. And the question is, how are we going to take this and make it into something that that the business can derive value out of, right? So I think to summarize where we were, right, as data scientists, we were building, we were extracting data, building dashboards, presenting PowerPoint packs, and on the side, we did do some ad hoc work with data science models, but it was never automated, and it was never really strategic, right? We had some models within the retail bank that were run kind of like once a month on an ad hoc basis. They'd phone you up and say, "Hey, can we please run this?" It just wasn't sustainable, given that we were just running like proof of concept, POC after POC after POC, and generating lots and lots of artifacts, because we were trying to prove our value as a central team to this business. And then you'd have people calling and asking you, "Hey, like how do I get that result again?" And you end up spending half of your month as a data scientist, where most of your work should be automated, doing BAU work of running models and extracting data, right? And so that's kind of where we were at. And I'll get into a little bit of what's kind of changed now. Because the one thing that you kind of need to understand is that data science and data engineering were two separate functions beforehand. Data science sat under the chief data office, and data engineering sat under the chief technology office. And ultimately, because there were two different functions, they were tracking two completely separate KPIs, right? And at the end of the day, if you don't integrate your data scientists with data engineers, especially in a time where data science is a new thing, right now it's quite established within the South African market. But when you took it out of in that space, data scientists want to build models, and data engineers care much more about resilience and making sure that they don't have to wake up at 2 o'clock in the morning to fix a production issue, you know? So those worlds were two separate things, and really the only thing that separated them, even like, I mean, physically, the data engineers sat about 5 meters away from me back in 2017, 2018. The only thing that kind of sat between us was a political wall, right? And so kind of what happened afterwards, right, is that there was kind of a restructure that went on, and we kind of merged the data science and data engineering teams together under the chief technology office. And this enabled a very cross-collaborative environment where data scientists and data engineers could learn from each other. And by structuring our teams around certain strategic projects, we built up expertise, and we also built up a team that was aligned to the same KPIs. Further to that, we also got to leverage a lot of the infrastructure that the data engineering teams had. So it wasn't that we didn't have infrastructure, we had a lab environment, but we didn't have access to the production infrastructure, or at least a means to get onboarded onto it, to actually create automated and sustainable solutions. But now we had the people and we had the infrastructure, right? The next thing was we kind of needed to pivot our business model, because the way of consulting into the business and running POC after POC just wasn't working. And the one thing that we realized is that within the data engineering, data science, now what we call the data solutions and data products team, we had really strong skills that from at that point in time, right now it's very different, but at that point in time, which was probably midway through 2018, was very unique within the organization. So when we realized that we were actually able to kind of choose the products, or at least the pillars that we wanted to align across, we managed to kind of we had too much work and too few people, actually. So this is kind of what we decided on, how we were going to go about choosing the products that we take on. So the first question that we asked is, do you have a problem to solve? Because at the end of the day, everyone wants data science and nobody that really knows what it can do for them. So ask them, what is the problem that you want to use data science to solve? And great, like you might have a problem that you want to solve, but you might not have the data, which I mean, there's a data in data science, right? And then lastly, is there somebody that understands this data, not just what the data looks like and what it tells you, but also where it comes from? Because at the end of the day, we want to be able to create a cohesive and full solution, right? We also pivoted how we deal with our stakeholders. Instead of coming to them and saying, what are we going to, like, what is your problem? And we're going to go and solve it, and we'll come back to you in a month with a solution. We start off the conversation with an education around data science. And the reason that this is important is because at the end of the day, you're optimizing some metric, right? You want to predict customer churn, and that metric that you're optimizing is people, the amount of people that you retain within the bank. And by educating the business on data science techniques, we are able to align the metrics that we are choosing to the business, and also help them to understand what that metric that we have chosen, how that aligns to their business process. So we actually take them through an entire workshop on data science, but more from a business perspective. And on top of that, we kind of added some extra layers, right, of data labeling and validation. And we actually, for supervised solutions, for where we need labels, or where we might need labels, we actually go through with the business and enable them to label some of their own data, so that they can take accountability and be involved in the process, right? We really want to bring them on the journey with us. And then also the validation of that data as well. So by providing them with the actual metrics at the end of the day, once the model's been run, give them a day-on-day, month-on-month tracking, you kind of give them the accountability and allow them to validate the results and give them that ownership, right? And then obviously knowing when to stop. Does the model need to be 70% accurate, 85% accurate? Set it up front so that we can quickly iterate afterwards, right? So at the end of the day, we moved from building POCs and notebooks to building products, right? We wanted to build a data product that people within the business and externally, so our clients, our customers, would be invested in, right? And to do that and enable the business to use these data science products, and also enable the analytics teams within the business. We wanted to build a platform, right? So when it comes to building a data science model, there's lots of different sets of requirements that you can have based on the business user, right? At the end of the day, you always have a model at the center, but maybe they want to see something through a UI, or at least the results of the model are presented through a UI. And then you have this training and labeling feedback, or maybe you need some integration through like APIs. Maybe you don't even need the APIs. Maybe you just have this model that needs to run and it outputs a file somewhere. It's at the end of the day, there's kind of like all these different pieces, and everyone within the business is kind of rebuilding these, and they sit like, you know, one over here, one over there, and they're kind of all over the place. And we don't collaborate even within our small teams. We never used to really collaborate on a project. It would all be kind of every man for himself, right? Excuse me. So we decided as a smaller team within this larger data products team. So we're about 22 people. We decided as a group of about 3 of us, small, but we've grown since then. We're now about 8 people, that we're going to build a platform, and we're doing this on a use case basis. So we're using use cases to build the platform to enable the business. And what this platform allows is, one, it allows reusable components, right? It allows standardized interfaces, and it's always evolving. So the idea here is that if you want to subscribe to our platform, you need to subscribe to a minimum set of requirements from your model. And it's very easy. You need to code in Python or Scala, and we're not even really all that prescriptive about it, because if the tools that we have, or if you're comfortable building APIs that can integrate with ours, then we're really agnostic, and you just need to house your model there, and we will give you the training and labeling feedback mechanisms and tools that we're using, the accuracy monitoring, the UIs, the integration. We'll give you that for free. And this is the community that we're creating around data science and data products. But at the same time, the reusable components make being able to kind of pivot and iterate very, very quickly. And our solutions that we're building, when we go into a first phase on a new project, we have all of this in place, right? It's very easy for us to do. But before we did that, as data scientists, we needed to change our development practice, right? Data engineers are ultimately software engineers. They've got a background in software engineering most of the time. Data scientists are kind of coming from all over the place. And if you look online, there isn't much of a focus on software engineering practices within data science. And we needed to change that. And this is where the cross collaboration really helped me. Specifically, it's selfish to say, but I learned a lot. We've got some really incredible engineering talent at Absa, and it really is unbelievable. So in terms of software engineering, we're really focusing on version controlling everything. So from a code perspective, we were using Bitbucket. We've very recently moved over to GitLab and GitHub Enterprise. We're just trying to figure out which is the one that best suits us and what's strategic for the organization. Version controlling our code, version controlling our data and our models to make sure that we have sustainability and reproducibility within our teams. We also adopted solid principles from a software engineering perspective. The reason that we do this is because we want our code to be easily testable, easily extensible by users, and easy to modify, or at least create new entities and adapt them for every use case, right? Integration is a big one for us. We have, as Absa, we are a amalgamated bank with a lot of legacy, and we want to be able to to accommodate for as many languages as we can and as many source systems as we can. And we do this through RESTful APIs. We build our own, and that's just how we do it. And then auditing, I guess this is in terms of code control. I apologize for the noise. This is in terms of code. We and our models, we go through rigorous code reviews to ensure that what we're putting out is really, really good. And this is both from a platform perspective and a modeling perspective. We make sure that our platform runs perfectly and that our models are fit for purpose. This wouldn't be a tech talk if it wasn't, it didn't have some tech information. So a lot of things here are probably quite familiar to you. On the right-hand side, from the deployment, we use ElkStat for monitoring and some visualizations. Deployment through Docker, we've actually moved off of Flask onto using Fast API, which is a new Python library for building APIs. It's Spring Boot below that, which is the Java implementation of APIs. I highly recommend Fast API if you haven't checked it, but I think there's one thing or two things. MLflow is a Databricks tool that's we use to track model performance and do our experiments. We do it all in one there. I think the one thing that kind of stands out here is the Absa open source technology, and our data engineers are amazing. I've said this already. We have some really, really incredible tools that they have created for us to, well, they weren't specifically created for us, but we are leveraging them, and they're open source, which means anyone can use them and anyone can contribute. Specifically, if you go on, we're using Hyperdrive, which is an ingestion tool from pretty much anything into Hadoop, and you get a lot of free stuff like conformance. You get scheduling. It's really, really great, and we're actually using Kafka to feed a lot of our data, purely because we can offload it into a lot of places once it's been onboarded onto the Kafka cluster. So the question is, where are we going from here, right? We want the business to drive a lot of what they do, right? I said we want to involve them in the process, but at the end of the day, we want to put everything in their hands, right? Obviously not put the entire model in their hands, but at least give them the opportunity to, or their ability to determine when something is going well and also when something is not. So if we create this full end-to-end cycle of data science, machine learning, serving the results, getting the monitoring, and this kind of feedback loop, and it's fully automated, we can do really cool things, right? If we put the monitoring metrics in the business hands and we give them a button to say, if this model is not doing well, press this button and we will do a model retrain on new data, and we will make sure that the metrics are not getting worse and they are improving. It becomes infinitely easier for us to step away from the process. Obviously, we still need to be somewhat involved because it's data science, it's AI, things can go wrong. But we put that in their hands to say, when is it not good enough anymore, right? And because we've educated them, they know, or at least they have an idea, and we're never all that too far away from the business. It's just how we've structured ourselves. The next thing that we do is active learning, or at least we're looking at, and this is the concept that if you provide labels for your data as your model is kind of like iteratively learning, you can improve it. So by giving stakeholders the ability to see, well, one, to label data, and two, to see how that's affecting the monitoring of the results, you create this accountability within the ecosystem. And I'm just on the right here, I'm showing you, this is actually one of our MLflow instances. The other thing is CI/CD. We've kind of got this right. to make deployments really, really quick, kind of pushing to some kind of master branch and kicking off a bunch of tests and stuff. I mean, that's another thing that I haven't really spoken about much is test-driven development from a data science perspective is something that we've had great success in. This is also really, really big. It's quite difficult, CI/CD, especially when you're managing it across multiple different systems, like prod, dev, UAT. But again, the technology office has some great tools that we're leveraging. The other thing is model monitoring, and I've spoken about this and we've gotten quite far with it, but things like triggers for when model drift is happening, right? And initiating a retrain when this happens, rollback for rogue models, and putting more rigorous tests around our production models. And then lastly, open source, right? We are heavily invested in open source as a bank, or at least as a technology office. We're really, really punting open source. And I really recommend everybody check out our GitHub repository as our Absa open source software page. There's about 18 different projects that we have on there. A lot of them are being used, well, I mean, all of them are being used within the bank, but a few of them are being used in other banks. For example, Spline, which is our data lineage tool, which we originally developed for BCBS, regulatory reporting. But it's turning into something really big. This is being used globally. We've been asked to provide support. There's some really great tools there. Cobrix is COBOL ingestion through Spark. So mainframe ingestion, it really is great. And I really recommend that everyone check this out and contribute to the page where you can. At the end of the day, data science is very much community driven, and open source software is community driven, and that's where we want to position ourselves as a community driven enterprise. Thank you. I do think that there's some time for questions, but you can also join me in the VIP lounge afterwards. And I'm happy to answer some questions there. If you want to get in touch with me, you can catch me over on my LinkedIn at Dan Wertheimer, or you can find all my details on my website at danwertheimer.github.io. Thank you.